The broadcast is now starting. All attendees are in listen-only mode.
Well, hello, welcome to Coffee with Caleffi. Hey, we're delighted to have Eric Aune with us today. He's a friend of mine. I've known him for years. We've never, in fact, this is the first time I think we've had to chew the fat a little bit and talk, but we see each other in passing. But I've admired his work and everything he does for our industry. I think we followed a similar path in our careers over the years, but I think we're a generation apart here. So it's interesting to see Eric kind of taking all this stuff with social media and taking it to another level with Mechanical Hub and all that he does. So I want to thank him, number one, for being here, and thanking him for being a friend to the industry. So a lot to cover. We'll hopefully have some time for questions at the end, but yeah, I guess we do have a couple references today. Those are basically fundamentals and good wiring practices in that middle issue number 14 that we did a couple years ago in 19. Probably one of my favorite when I do training presentations. I always take 12 and 19 along. It just shows basically some of the mistakes that are made out in systems there and the correction for it as far as piping and stuff like that. So those are the issues that would most apply, I guess, to today's topic. Thank you. There he is. There's our guy. So thanks for being with us here today. If you see Eric out there on the streets or out in the shows and stuff like that, certainly say hi. He's a personal guy and loves to chat. All right. I think the next one is your kickoff. So
thanks a lot, Bob. I'm happy to be here. I just want to give a quick background of what I do on a daily basis, and really that's what I want to cover in this webinar. A lot of things that a lot of the jobs that I visit are bringing me in as a second or third service contractor to fix problems that were created on the install for hydronic systems. I want to go over some of the installation tips that I see often are mistakes made on the job. I'll offer up some solutions to those common mistakes. We'll talk about maintenance, tools, training. We've got the questions at the end, of course, so we'll get started here. Really, when it comes down to installing for a new install or even a retrofit, there's a couple things that are often overlooked. I see and I talk to people all over the country, and it's pretty common to hear people say that they just aren't reading the manuals. And I'll be totally honest, I'm guilty of that for many years as a contractor, but I've learned just how much of the information we need for proper installs included in those manuals, and these manufacturers are taking the time to put that information in the manual. It's, I think, really up to us to be successful with the install or with a retrofit application to take that information and know it going into the job. And then, of course, planning ahead. We've got some slides in the upcoming presentation here that really show a lot of good work or work that could have been done better if a little bit of time would be taken ahead of time to plan the install. And then, of course, just verifying everything is working properly. I can't tell you in 20 years how many times I've been called in by a frustrated homeowner or a contractor or even a building owner saying that they've got a new install that they paid a lot of money for, and they're turning the heat on for the first time and it's just not working. So I think it seems common sense for everyone to verify that things operate properly, but apparently being whatever it is, maybe our schedule or wanting to get on to the next job, or maybe you just don't feel like you're getting paid for it, but it really can cause problems down the road if you're not verifying things are operating properly before you sign everything over. So a lot of the symptoms that I see are the causes of problems on these calls that I take almost every day are really put in order here. See a lot of venting problems, piping seems to be an issue, and then certain components that are just installed either incorrectly or close but not quite right. And then, of course, we've got a couple technical things I want to talk about later on as far as hydraulic separation. I know that some of the questions that were pre-submitted for the webinar were asking about that. Seems to be a pretty common topic of conversation either online with social media or interaction on different chat rooms, things like that. So we'll get right into it with venting. Here's a couple pictures. One of them was sent to me, that upper left there. As you can see, it's a intake and an exhaust tied together, which I'm not exactly sure how that happened, but apparently it did. But then also, if you look to the bottom right, that's a picture I took. In Minnesota, we have the opportunity to build these really cool, I call them ventsicles, on the outsides of our houses or buildings, where you've just got probably improper termination of the venting on the outside. And really what I'm getting at is this next slide here. And it goes back to reading that manual. So much of the information, or all of the information we need, is contained in probably even just this one graphic alone, but I'm sure everybody attending here who's been out and installed equipment on the jobs has seen this graphic or something like it. We tend to ignore it probably because it's a hurry to get the equipment in, but it's critical because of those nuisance callbacks where you've got equipment that's shutting down, especially this high efficiency equipment that's venting in the sidewall or out on, with the plastic piping, causing shutdowns because of air sensors or temperature limitations, things like that. A lot of that can be solved, honestly, in my opinion, by looking at these graphics in the manual that show us where we have to be and how to terminate piping on the outside, whether it's through a wall or through a roof or different configurations, all the different types of venting options that are available. And honestly, I've never seen a piece of high efficiency equipment that didn't include so many different variations on how their equipment can be vented. And I promise you, if you follow them, you're probably going to be a lot better off than if you're just not reading the manual. I don't know if you have anything to add to that, Bob, as far as venting goes, or
No, I think you brought up some excellent points there. I think it's probably the biggest chapter in all the installation manuals is venting. It's like the first third of, it seems, all the installation manuals, and I think people just glaze over. But you're right that these 3 slides that you put up there really sum it all up. The distances from the ground and from the windows and stuff like that are really the key to that. I think brand by brand, they're all going to be pretty similar as far as, the spacing they want and stuff like that. But, I think a lot of manufacturers too are starting to go to more training, installation tips and stuff like that with the QR code or something like that, and have just a short YouTube video that maybe the newer guys are more apt to watch a video than read through 30 pages of bending text on there. But no, this, in a nutshell, these 3 slides are really, they're going to keep you out of trouble.
Yeah, and I could have picked 100 slides on this one topic. Like you said, it's honest, oftentimes the first third of the manual. It probably gets paged through quickly because so much of that venting section might not even apply to the installation that person is standing in front of. But
Yep.
I guess really what I want to stress is knowing this ahead of time. You can make your job a lot more efficient, the install go a lot faster. And ultimately, whether you're the owner of the business or not, you'll make more money with this, preparation ahead of time. So it's not just about eliminating the callback, although that's the goal, but it's, knowing this ahead of time is just going to make the job smoother, easier, and you can focus on other things that are going to be a challenge that are going to be a challenge, whether or not, especially with retrofit applications, there's not always the amount of space you need, or maybe you missed something in your notes and you have to add some more connections. And, the last thing you want to be worrying about is something so critical as venting and spending a lot of time on the job trying to figure it out. So knowing this ahead of time and knowing that this information is all right there for you, whether it's a new piece of equipment or something that's familiar, you've got the reference information right in front of you every time.
Yep.
So here's a little checklist, and this is actually, you'll find some of these, something similar to this in some of the more major brand boiler manuals. But I have this in my clipboard. It's in my truck. I probably don't look at it every single time, but I have looked at it many times. I've tried to commit it to memory, and I don't need to read it for you. But honestly, it's going over those layouts that you see in the manual. You got to maintain your clearances, your spacing. You've got to be able to service this stuff in the future. I know that there's there's physical limitations on the job where you can only go in one place, and maybe it does meet all the specifications, but you think how are you going to get to it in the future if there's ever a problem? And you do have to inspect venting later on, and especially if you get called out for a problem that's related to the venting. So, and then some technical stuff like if you're using the room air for the venting of appliances, I see that quite often. And honestly, it's not maybe a major cause for callbacks that I see, but I have ran into it where installers aren't taking into account the information needed that's presented in that manual, showing the required room air if they're not using a direct vent system. Seems to be quite popular. Different areas of the country they're using room air. So know those specs ahead of time, and then make the changes that are needed so that you're not getting called back. And then something I talk to my owners all the time about people love to store their extra paint in their mechanical rooms. I don't know what that's all about. Apparently it's just the go-to place to put all that extra paint, but that stuff's got to get out of there if you're using room air. So we got to move on here and talk about piping a little bit. And so we see a lot of times I see a problem with boiler piping. It tends to be undersized. I know you've probably seen that quite a bit yourself, Bob.
Yeah, that's. I think they think whatever connection comes out of the boiler, you got the permission to reduce it or use it whatever it is for the piping instead of figuring out what the actual flow rate needs to be through that little what's a munchkin looking or a peerless looking boiler there.
Yeah, so this is quite a famous boiler for probably anybody who's been around for more than about 10 or 15 years. I've seen quite a few of these out in our area here in Minnesota. They're quite popular early on in the ModCon sales, but this one in particular is piped direct to a radiant manifold, and that's the whole system right there in a nutshell with 3/4 inch piping. Now, of course, the load of the system itself could probably be served well with 3/4 inch piping, but there's no hydraulic separation. And connecting it direct like that with the type of heat exchanger that's in that boiler, that's a Aune water tube style heat exchanger, and has a lot of head loss in it, high head loss, so it requires quite a bit of flow in order to operate properly and not overheat. And you're just not going to achieve that with this type of installation, piping direct first of all, and then with the small diameter piping being that it's 3/4. That boiler itself actually has 1.25 inch connections on it. So reducing from 1.25 inch down to 3/4 is like you said, it's almost like I often wonder if this is the cause of this is because that's what pipe that they stock on their truck, or if that's what the shop sends them out with. I'm not exactly sure. It's lower cost, of course, but it's going to cost more in the long run to fix it properly. Yeah, I see a lot of undersized piping. I'm sorry, go ahead.
They had connected 2 dots there. The manifolds had a bigger connection size that they pushed down, and the boiler they pushed down with things. It's like, well, there's a reason those are that size on both ends. So I don't get it either. It's that's what you have on the truck, or that's all you can afford, or whatever. But it just it's a common problem out there. Is just undersized and not getting enough flow.
Right. Yeah, and for anybody that might be wondering what this may cause, what kind of problems. So really, ultimately, what's going to happen with this boiler, and what was happening with this boiler. This is a picture that I took. I was called out because they had owned this boiler for about 10 years, if I remember correctly, and it just never ran right. So they didn't use it very often. It was supplying heat to an unfinished basement. They finished their basement, and then so they're spending more time down there, and they realized it just wasn't heating properly. They just were never comfortable. And the reason why is that boiler would lock out all the time. It would just go out on high limit and then reset itself. And so it was actually, the boiler itself was operating perfectly fine. It's just, it was limited to the piping that was connected to it. And so the end result in a situation like this is a boiler that's short cycling, that's not operating properly, and you just can't deliver the right amount of heat out into the system. Eventually, because of the natural course of events on these people living in their house, they finished the basement, they realized it wasn't working, they had me come out. You just stand there and you look at it and go, oh boy, we have to do a lot of work here. And really, ultimately, is take it out and replace, at least, at the very least, the piping and the components connected in between. Which brings me just to this really simple graphic. Here's the chart on the left. Those numbers are taken specifically out of the Copper Development Association manual on pipe sizing for heating systems using copper or steel. And it's really just a reference point. I don't want to say that this is I'm not claiming technical accuracy here, but if you look at the most typical size piping that you'd see in a residential system, really your 3/4, 1 inch, maybe 1.25 inches, 1.5 inches. For boiler pipe sizing or distribution sizing, if you know the BTU load, which using that simple formula on the right, you can come up with the gallons per minute needed in any part of the system. You can look in and you can quickly verify whether it's existing piping or you're installing the piping new, what size you may need based off that gallons per minute. So oftentimes I see 3/4 inch pipe where 1 inch would be used. Use this formula real quick. It's a kind of a fast and loose calculation. It's not the most technical, but it gets you where you need to be. And I promise, or at least based on my own experience, that if I came up with 7 gallons per minute, and I used 1 inch, that it's going to work perfectly. But if I use 3/4, I'm probably going to cause problems down the road. So I just bring that up because I think it's useful information. Anybody that might be referencing this in the, later down the road, or if you want to take notes or find this information, the Copper Development Association pocket book on copper installation, this information is there. You see a lot of great companies in their training, like Caleffi, using really the same type of information, just showing people this is about where you need to be if you're using copper or iron pipe, based on your gallons per minute for sizing. I don't know how you feel about that formula there, Bob. I wanted to note that it was kind of a fast and loose, it's not the most technical, but it gets people in the right area.
Yeah, I mean, it gives them some numbers to hang their hat on. It probably conservative on those numbers on the left there. That's probably 2 feet per second flow rates, but like you say, it'll keep you out of trouble. It's just good to know. And there's a lot of this information is available so easy these days. If you've got a phone or a computer, or a tablet or something with you, there's engineering toolboxes, all sorts of free online calculators that can help you with the math if you don't want to do it, or give you charts like this that'll give you a quick reference for sizing, valves, pipes, fittings, whatever it might be.
Right. Yeah. I'm constantly pulling something up. If it's not an app already on my phone, Google is your friend when it comes to trying to figure out technical information like that, at least, maybe just to help you diagnose a problem on the job. But again, just in review, I see a lot of undersized piping. Most of the time it's because people aren't referencing any type of technical information, whether it's that Munchkin boiler we saw there, that I'm not sure how that landed on the job site, probably just what they had on the truck, I guess.
Yep.
So another topic of that I see a lot, or problem that I see a lot, are mixing valves. And I've learned more from Caleffi about mixing valves than I can say from probably anybody else. But honestly, if I see these valves installed incorrectly quite often, whether it's on a hot water recirc system, but or in this case hydronics, it's, again, the manual is your friend here in this situation. But just for quick reference, of course, every mixing valve on a hydronic system, when you're using forced hot water like this, the pump needs to be placed on the mix port of the mixing valve. There are some other guidelines that have to be taken into consideration. Of course, you need to know pipe sizing as it's affected by the type of mixing valve you're using, whether it's motorized or manual like this one shown here. But you know, this is an old installation, been up and running for about 20 years, and it's that type of situation where you're told by the owner, well, it seems to be working fine, and that might be so. Maybe they just don't realize that it could work better. But in this case, that circulator is pulling off the return of that secondary loop, and it's trying to pull the proper mix temp through that mixing valve. And I'm not sure that it ever has worked properly, but again, you're told oftentimes that it does. So I don't know if you deal more with mixing valves, at least on the educational side, Bob. You see a lot of, is there a lot of confusion on these, or you see a lot of installs like this when people show you pictures or anything like that?
Yeah, I mean, mispiped three-way valves, mispiped and undersized are probably the two biggest things. I don't realize the pressure drop through a valve like that. And, the other thing in this picture is, can't see it, but he's probably pumping at the expansion tank too, the way the pump's on the return side of that. So I will say he's got 80 degrees going on at this point in time. So the thing about hydronics, it can be pretty forgiving. You can make some mistakes and you still get away with it sometimes, like that previous little green boiler and this one, I guess they did a little bit of work, but certainly not up to the expectations of what they should do and what the customer paid for by any means here. But yeah, just judging by the color of that Grundfos, this is probably a 1990 something installation. And yeah, it's just, it's probably the first page of every manual is a little piping schematic on there. It's a pretty simple valve to pipe in and put the pump in the right location, but I don't know that it'll ever end, but we hope more people, take the time to get the components in properly and sized properly.
Yeah, and one more thing I want to add to this, just to this based off of serviceability. There's a lot of great components out there, and I don't need to be brand specific by any means, but I'd like to pose a question to everybody here. How would you feel about having to change that circulator? And I bring that up because isolation valves are so inexpensive. And I know it was less expensive to install this pump without the valves on it, but when it comes time to replace that pump, and this pump is actually still running this way, unless the owner went with another contractor to replace the boiler and make any changes. But as far as I know, it's still operating this way. And that pump, and good testament to the quality of that pump, but I wouldn't want to be the contractor to have to replace it because of the amount of time that'd be involved and the expense to the owner.
Yeah, not a good purge port there either, but interesting, the pump on the other side had a valve on it, but at least one valve, so who knows, maybe he only had a valve on the truck that day, so I said I'll put it on one of the pumps.
Yeah. Oh my goodness, I found myself in that situation too many times. A valve on the truck, I'll be honest. Now let's move on to air. So this is a cool picture sent to me by a friend a while back, but shows a few different symptoms that I deal with on a regular basis when doing service. It looks to me as the fix here was to address a leak that was happening on that air elimination valve, and they did that obviously by adding another valve because that's the most logical thing to do. But probably a situation where the system, the water quality, maybe had compromised that automatic air vent. Maybe the boiler was operating improperly, it was overheating or something like that, caused the failure of that valve, but obviously not the best fix in the world. I guess maybe it did the job at the time. Some of these photos.
What the thought process there was, whether it, he wasn't doing a good job of air removal, and he thought maybe adding the second air vent would improve the performance, or that, like you say, more likely that it started to spit or drip or leak a little bit, and that was the fix. He had all the bushings and parts with him to do it though, so must have come across this before.
Yeah, he had a reducer 90 on his truck. Lucky guy. I never seem to have those when I need them. Here we go. So moving on with air, we've got an expansion tank. Well, according to that manufacturer, it's installed incorrectly. But you see the only air elimination on this install is that little high vent there. And we can talk about it. We can get into air elimination, and I can address it by saying this: it's done most productive. Your most productive air elimination, or most effective, will be at the hottest point in the system. Depending on the type of device you're going to use, like shown in the last slide, that automatic air elimination valve, those can be installed either, depending on the model, either vertically or horizontally, but best installed at the hottest point in the system, and then not but directly in the path of flow. So like this particular install, you can see the pipe is the supply pipe to the system, and there's a low water cutoff valve and then the expansion tank. But that air that air vent there, I don't think is really going to do anything unless but maybe bleed that tank out on the initial install. Missed opportunity, I guess.
Yeah, I'm a little confused. It almost looks like that's on the return pipe too. Isn't that the supply of the pipe to the right? And so it's pumping into the boiler away from the expansion tank.
Oh, no, yeah, no, you're correct. I misspoke there. Sorry, that is the return pipe. I didn't see. Oh, it makes it even more interesting.
Yeah,
but
the double whammy.
Yeah,
there.
I mean, you just don't have any effective air elimination there. Maybe there's air vents. It looks like 3/4 inch pipe going out on the supply side. Maybe it's a baseboard system or a radiator system. Could only hope, I suppose. Yeah, this is interesting. But here's what I'd like to talk about for sure. I see air scoops installed incorrectly all the time. It seems to be one of the most common things I see on older systems and new systems. Whether or not you're gonna, you believe in the automatic air vent, that's fine. But these air scoops are designed to operate relatively efficiently, but only if you install them properly. And I'm not going to put up any graphics showing the dimensions because each of the manufacturers are going to cover that in their install literature with the device. But these air scoops are designed so that they operate when the flow velocity is at a minimum on the inlet side of that air scoop, and that's really the only way you're going to capture the air efficiently out of this. In order to do that, a lot of the manufacturers are saying you need about 12 to 18 inches of pipe leading to the inlet side of that air scoop for that velocity to slow down enough and to allow that air to rise to the top, basically, when it enters that valve and be captured by that automatic air vent at the top. You're not going to get that in this situation. You can see coming out of the boiler 490s, which is going to create a lot of turbulence and is going to increase the velocity of the water running through that section of pipe leading into that air scoop. This one obviously has been in for quite a while, and you can see that it's leaked plenty prior to me snapping this photo. But I can't imagine that it was very effective that entire time for however many years before, that it was in place like this. You see that I'm sure you've installed your share of air scoops, Bob, but you see a lot of people that just aren't quite getting it right on this piping configuration. Yeah,
rarely do you see, that 18 or 24 inches, whatever the manufacturer wants, a straight piping upstream of that. I don't know why, and I don't know why if this guy was getting paid by the elbow that he put in, or why he's got maybe a swing out because the pipe coming out of the boiler didn't come out plumb or something. But it just seems like you took and kind of complicated the ability of that to do a good job. But yeah, that you see him out there.
Yeah, that's interesting. No, but a little bit of an older application as far as the device goes itself, but they're still I wouldn't say they're uncommon at all. still being installed. Of course, the automatic air elimination valves, they're going to address this situation. They're a lot more effective at removing air, and they're not reliant on a certain amount of pipe on the inlet side of that. So that might be a lesson there too, just to know that, the newer technology, the newer valve is going to allow for a more flexible installation.
Yep.
Threw this in here because I thought it was interesting. What do you call that? A 10-pound relief valve, right?
I guess if that's a 10-pound sledgehammer, I guess that's what you get is 10-pound relief.
Yeah. No, leaking devices, we see that all the time. That's an indirect water heater, of course. Just something I wanted to include today, because you really do see some crazy stuff out there, and some ingenuity on how to address the problem, however temporary, hopefully, this was.
Do you think they sacrificed the handle on that sledgehammer and cut it down to fit between the floor there and the relief valve?
Well, I was just thinking that myself. They had to, unless the angle of the photo is just playing tricks with us. I'm not sure.
Or maybe they put a hole in the floor above.
Yeah. Just drill a hole right through the floor, and got to use that sledgehammer sooner or later. Serviceability, just cleaning things up. Here's a job that I didn't get any after pics. It's really my fault. But here's a recent project that I worked on. We had to add a zone, and then of course in that opportunity, I took the opportunity to sell new zone valves. Not that there's anything wrong with this particular brand of zone valve, just not what I prefer. Either way, look at the wiring. Think about the next person in line and what they're going to have to deal with, or yourself if you're going to be the one coming back to service it. So got just a rat's nest of wiring. I think there's another slide here showing, really, there you go again. Those Honeywell zone valves are common in my area. This type of wiring is also very common. It's a great source of income for the service contractor, because you're going to spend a lot of time in front of that, but that's not really how I'd like to run my business, or be known by my customers as somebody that caused them problems down the road or cost them money. So these can be addressed with your zone valve control relays. Caleffi, of course, makes a whole array of those that are very dependable. Couple them with your zone valves, and you're going to have a nice warranty too. I like the caption on this one here. So you got a micro load, I suppose, with that 1/4 inch or 1/8 inch copper there added to it, the saddle valve. Not my picture, was one shared with me, but again, opportunity for people coming in after you to take advantage of your well accessible piping. I probably was feeding the line to
a tap line to put a dishwasher in, maybe. We hope not. They wanted high temperature water in the dishwasher.
Yeah, I'm thinking possibly a humidifier. Hopefully not an ice maker.
Not an ice maker.
And then just more components. I mean, people get creative. Here's a flow check with a relief valve on the port. Nothing technical here, just another thing that we see out on the job site. That flow check would have had a cap in the bottom of it. I'm not exactly sure. I wonder if that relief valve was their cap instead. But interesting nonetheless.
Jeez.
Still on the topic of air elimination. This is just a photo from in my shop. I'll address this later again, but one thing that we see with these wall hung boilers oftentimes have connections out the top, depending on the design of the maker and model. But it's been my experience that nuisance callbacks are oftentimes related to air in the heat exchanger. These things will go out on high temperature limit, shut down either on soft or hard lockout. And I have to be upfront and say that took me quite a while to figure that out. What maybe some of the problems that cause that, and I've been just in practice of using automatic air vent at the top of that heat exchanger, and that can really service you and your client well, especially on startup. But of course, problems arise down the road. This thing can do a lot of work for you and keep you from coming back to reset a boiler because there's some air in it. So just a note there, this boiler obviously laying on a pallet on its side, but as it, that air vent is going to be at the top of that heat exchanger on the supply side, and it's going to take care of any air that's going to be captured back into the boiler, especially after, shortly after startup. I don't know if you have any thoughts on that, Bob.
No, in fact, it looks like, did you put a coin-op vent on the other one too? You got a manual vent there and then the little float vent?
That's actually, that was a factory installed fitting on that heat exchanger. So that's the return pipe. And so I guess there could be a vent there as well, an automatic air vent, but that was the coin operated vent there. It was just factory installed. That's a lock and bar night boiler.
Yeah. No, that's a good point on that. What we would call a high point air vent. That just makes sure that you get the air out of the heat exchanger, that boiler, when you fill it up the first time. I mean, that's not going to replace a good air separator like you mentioned on the previous slide, but it certainly protects that boiler to try and keep the air out of the heat exchanger itself at the boiler.
Yeah, it's useful at not only, I want to stress though that it's not only useful at the filling the boiler initially, but these systems, whether it's radiant or you've got long horizontal runs and baseboard systems, you're going to have trouble getting all that air out on the initial install or fill. And there will be air in the system. We know that. There always is, just a little bit, and it seems to present itself in the least serviceable places, like a boiler heat exchanger. Just adding a simple device like this can really help quite a bit.
Yeah. Looks like a Caleffi too, so it doesn't get any better than that.
It is in fact a Caleffi. I couldn't tell you the model number, you'd have to know that, but yeah, useful. I found that it's all about, in my business, it's, well, especially in retrofit, we're shutting these people down for a day or so, and that's an inconvenience, but even more of an inconvenience to them is if we got to come back and solve just, small little minor problems that can, take more time out of their schedule. Small investment here takes care of a lot of problems, in my opinion. And then we'll just tie the two improper pipe sizing and air elimination into one here. Again, that common boiler that was pretty popular years ago here. This is a job that I snapped this photo on. Got a mixture of piping. That's interesting. You've got the minimum distance of the pipe going into that air scoop is incorrect. You can see that thing has been leaking like crazy, probably overheating. And then, of course, what you can't quite tell in this photo, but you'll have to take my word for it, is this was piped direct to 3 separate radiant manifolds for in-floor heat, and no hydraulic separation. Small pipe size, 3/4 inch. You can kind of tell on the back wall there behind the boiler. Then tied into some galvanized piping, which maybe isn't the best for hydronic systems, or at least in my experience. But 2 pumps running that system in and out of the boiler, because one was probably added after the fact because they weren't getting the right flow, and that comes down to the pipe sizing not being correct, and then not separating that boiler by piping it direct.
I think you call that a push-pull system. I'd wonder about the size of the gas line too. Looks kind of questionable.
Yeah, 3/8 copper. That's not uncommon here. We use high pressure inside the house, so that's coming right after a regulator. It's probably, I think that was maybe a 55,000 BTU boiler. This is probably fine, believe it or not. But it, judging by the rest of the piping, I guess I don't want to say for sure, but it could have been wrong. I wouldn't argue that.
It might have been
Yeah,
a do-it-yourself install. Not do-it-yourself or with all those galvanized nipples that you would buy at the, at the box store or something.
Yeah, we got a word for that around here, and it's not meant to be derogatory, but it would be farmer plumbing. It's probably you probably hit the nail on the head in that it could have been a do-it-yourself project. Either way, you can see the wiring going in one pump, out of that same pump over to the other, so they're both turning on each time that boiler gets a call for heat. Just a messy situation, really. And it was completely avoidable had that boiler, but had they looked at the manual and just said, okay, this is the way the manufacturer wants it installed. Those boilers actually, have created a lot of income for a lot of heating contractors, I'm sure, in service. But there really weren't a lot of things wrong with that boiler. Ultimately, if it was installed properly, it worked pretty well. It's kind of another discussion for another day, I suppose. And then, not to leave out gas piping, but this is an install I did at a car wash a few years ago, and another contractor was subcontracted to do the gas distribution inside the building. This is a retrofit application. Tore out a big tank, put in some tankless units to service a small self-serve 2 or 3 bay car wash. And I bring it up because it's common in my area. We use, like I said, high pressure gas, typically into the building, whether it's a house or commercial building. It's going to be 2 pound. And then we're using regulators either for the whole home or building, or a regulator at each place, depending on the size and the demand. So these were 200+ thousand BTU tankless units that were probably best served just having their own individual regulators. But those regulators are installed in the improper position. More information you can get out of the manual, of course. I don't want to sound like a broken record, but it's the truth. The remedy for this situation is just to add some more piping and turn those regulators horizontally. But again, it comes back down to reading the manual and then verifying operation. Those regulators will operate, but unfortunately intermittently, because they won't operate properly. Those are diaphragm regulators. So in that position, they're not going to close all the time or open properly each time. So not only can you mess up the piping on the water side, but you got to take a look at that gas piping. And of course, we already covered the venting. That's a common vent system, and it met the regulations for our local code and the manufacturer as well.
There's copper
And
work.
then this. Oh, thanks. I press that stuff, of course. Anybody that has followed me for a while knows my feelings on that, but I love it. It's fast, quick, and easy. Go back to this venting, to stay on the topic of venting or just improper install. This was a picture I snapped on top of a boiler here. I thought it was interesting because it looks like somebody prior to me came along and did a combustion analysis on this piece of equipment, but by drilling a hole in that exhaust pipe, and then their fix to cover that hole was to put some foil tape over it. I don't know if that's a Minnesota thing, but I see it all the time. And what was most interesting to me is if you look at the vent collars on that boiler, they give you a port on both the intake and the exhaust for placing your analyzer probes in, but yet they just chose to do it on their own, I suppose. Maybe it was up against a wall and they couldn't get their probe in the side, the way that vent collar is positioned, but I'm not sure. Interesting nonetheless. Brings into question, whether or not that's something that you can trust. Me as if it were in my house, I'm not sure that I'd trust that piece of foil tape on the exhaust port of that boiler. I don't know how you feel about that, Bob.
I would say it's probably not an approved method to get into that. I wonder if that collar on the left got turned a quarter turn. You would have thought that both the access ports would be to the front. Maybe it got spun and, like I say, it was too close to the wall to get his probe in, so somebody just drilled into it. Get her done.
Interesting. Yeah. Well, and if it got turned, that means it probably could be turned again. So, just taking the time to figure things out.
Yeah.
Well, it should be noted that I'm impressed that the combustion was checked in the first place. So
Yeah, well, I was thinking the same thing. The good news there is somebody probably did stick something in there and take a reading on the exhaust there and maybe dial it in properly. So 50%.
yeah, A for effort. Now we get into hydraulic separation. I'll probably lean a little bit on you, Bob, because I don't want to misspeak here. But this is something that I get messages on social media, through our website, talk to get text messages, talk to people all the time about. I am by no means a leader in this, professing this technology, but it's pretty simple to understand. Some of the questions that were submitted ahead of time talked about hydraulic separation. We'll just start with the most simple of them all, and that would just be using primary secondary piping with closely spaced tees. These diagrams are out of the Hydronics manual number 15, as you see there, and these are drawn, I think, by John Siegenthaler. Is that right, Bob?
Yeah, probably out of one of the idronics, and I would say those same drawings appear in a lot of installation manuals and some, version of that, like I say, that primary loop method on the left there is, I know I've seen that in manuals as one of the options for proper piping.
Yeah. What I see oftentimes installed on jobs is probably the diagram on the right. The diagram on the left would be a series primary loop. In that configuration, what you've got is your boiler connected with closely spaced tees. The theory behind closely spaced tees is to minimize the distance between the two tees, so that there is little to no head loss through those tees. And that's where your separation between the two loops of the two hydronic loops there takes place. The reasoning for minimizing the head loss between the two tees would be to ensure that that primary circulator, the flow through that loop, is not inhibited by sorry about that, the flow needed at the boiler. And the reasoning why you would separate a boiler, like we saw those direct pipe boilers previously, is because there's a minimum flow required at the boiler, so you get the proper temperature control and injection into the system. And then, of course, that being oftentimes different than the flow requirements on the system side or that primary loop. What I see more often, like I said, is going to be systems that are intended to be installed like the diagram on the right. Same type of configuration where the boiler is connected, but not the series primary loop. What the difference between these two diagrams, the diagram on the left, the series loop, is going to introduce the return water off of that first hydronic loop is going to mix with the supply temperature in that main primary loop, and then that second loop is going to be lower temperature on the supply, that third loop lower yet, because you're mixing the returns from each of those previous loops as it feeds on to the next. And that's fine, that works well, depending if you know exactly your return water temperatures and you know what you need to supply for the emitters on each loop as it goes down the line. Probably a little more common, like I've said, is going to be a installation like the one on the right, where you've got, in this case, as it's drawn, a single temperature, and those return water temperatures aren't going to, they're not going to they're not going to mix down for each individual circulator as it goes down the line there. They're isolated from each other, so you've got a single temperature rather than multiple temperatures in that loop. I don't know what would be more common for different areas, if that's, if there's a preference for different contractors. I've done it both ways here, but it seems to me to be a lot easier to install your primary secondary loop in this fashion as shown in the right slide, right graphic there. Take note though that your piping sizes have to be sized for the full load on that primary loop. And then of course, one of the questions related to primary secondary would be the minimum inlet and outlet for pipe size or pipe distances, I guess maybe is the best way to put it on those tees. Bob, do you have anything to say about, how much pipe is needed to go into a tee or come out of a tee on a primary system, primary, secondary?
Yeah, no, you hit all the good points on that, and the difference being that you got a series primary loop on the left, and you got a parallel loops on the right, and the one on the left costs you an extra pump just to keep the conveyor belt going, so to speak, or on the right. But yeah, the distance between the tees on there would be similar to on a primary, secondary. You want to have usually 2 pipe diameters or 6 inches or so between them. And then the reason that the lines are bolder on the right there on that kind of horseshoe, if you want to call it that, or we're trying to indicate that you got to size that pipe bigger. So if you had those pumps where you got 3 big pumps and 2 small pumps, let's say you've got 10 gallons each on the big pumps and maybe 5 gallons each on the small, so that comes up to what adds up to, I think, 43. Just kidding. You'd have to size that pipe in that horseshoe to, accommodate the flow for every one of those pumps running. So, the devil's in the detail on all these piping schematics is, like you start with the first slide, is the pipe size has to be right, or those pumps are going to, starve for flow. And obviously the check valves are more important so they don't pull from one another. But we see this as a more common way of doing primary secondaries with this horseshoe loop, where you get away from your temperature drop on the series and get rid of one pump, and it kind of cleans up the amount of fittings and time and labor to put that together also.
Yeah, definitely faster on the parallel for the install, and like you said, makes a big difference to me. It's going to take less fittings, and that's a lower cost install. So yeah. And then of course, moving on with hydraulic separation, you've got a low loss header option too. This is really going to take primary, secondary, or hydraulic separation to a whole different level than using closely spaced tees. Obviously higher cost. You're investing in that low loss header is going to be considerably more expensive than a couple tees, but it's going to achieve a lot more than a couple closely spaced tees are. And that, a lot of your low loss headers are going to also include an air separation, maybe a gauge port, drain at the bottom. They're going to allow for maybe magnetic separation as well. So really all a low loss header is a giant pipe in the system that's going to slow the velocity down. And that's where your isolation or separation between the 2 different flow requirements shown on this graphic are going to come, and that's going to take place all on that one device. Simple install, very straightforward. I get a lot of people asking me where the expansion tank gets installed on a system like this. I know I've even emailed or called or maybe texted Bob on that years ago because it was very confusing to me too. Most of the information I've seen is probably from John Siegenthaler, showing the expansion tank being on the return side, whether it's on the boiler side or the system side of that. Low loss header seems to be the consensus for installing the expansion tank. What do you think about that, Bob?
Yeah, exactly right. And that's why we try in that dotted blurb there, that whole pipe to the right-hand side on the bottom, the blue line, the return on that hydraulic separator, that whole thing becomes your low-loss header common piping. So that expansion tank at the end of that header, it establishes a point of no pressure change for the pump at the boiler, as well as the pumps on the upper side. It could be, like I say, on the left-hand side of the bottom of the separator, it would accomplish the same thing. So you got a little bit more flexibility there than you do in the primary loop. We'd like to think that the separators are kind of replacing primary, secondary with the closely spaced tees for all the reasons you indicated. You get more bang for your bucks, and you avoid having any pumping conflicts with it, and save a little labor, a little time, and and get the multi-function device. And I think you're seeing more and more manufacturers are starting to either show this drawing or in some cases even offer a hydraulic separator in their package. You can buy their boilers and get the separator right from. I know Beastman for years has offered a little low loss header as a piping kit or an option for their systems because they want to make sure it gets done properly.
Yeah, that's a good point. A lot of these manufacturers are offering like a boiler manifold. I think initially people are looking at that as a possible way to save time on the install, which it does, of course, but it's offering really the proper type of separation, hydraulic separation, whether it's a low loss header like it's shown here or just even a primary secondary type of manifold, which I was looking at some of the questions earlier that were submitted ahead of time, and one of them was asking what's the minimum, we can do. Yeah, we can put in a low loss header, great device, but depending on, the budget of the project or really what's needed, maybe it's a very small system and there's only one single load, but you've chosen a boiler. Of course, hydraulic separation is the minimum you can do. Or what the minimum required to do that would be closer spaced tees, I guess is how I'd answer that. You're not going to get all the benefits you would out of a low loss header, but you still have to maintain that proper flow rate through the boiler so it's operating properly, minimizing the callbacks, and then of course the delivery on the system side.
Yeah, and we will, that's a good point. We'll get to all those questions that were pre-submitted. We're probably going to run out of time today to get to them at the end, but we will answer all those. And there was a lot of them about piping, so that's, we'll make sure that we get back to you on that. And I think you've cleared up a lot of the questions just through the presentation that came in, but just so the people know that we'll get back to on the ones that we can't get to today in the time we had.
This is just a fun slide. I'll keep moving. Man cave, I guess.
I question what's going to go into two blue boxes where he's got that space taped. What is he going to put? Maybe a bidet or a sink there, or maybe a hand dryer or something. I'm trying to figure out what's going on with this planning in this picture.
I know, isn't it great? I was trying to read the writing out of it. I love it. I'm lucky people share these fun photos with me.
Yeah.
Here's a job that I did a few years back. This is a church. And I bring it up just because, again, thinking about the next person and all these components in these systems just need to be serviced. That's a reality. I don't know anybody that would think otherwise. And the way this system was installed, I don't want to be the guy. Well, I was the guy, I should say, but I wouldn't want to leave this up to somebody having to come back and service this. Those zone valves all lined up there like an army behind those 6 and 7 inch Class C vents. Those things were burning hot, and really the only remedy in the situation is cut it all out, in my opinion, and relocate those valves. But luckily, I was there to do a full boiler replacement for the 2 boilers, and we were able to move those valves. But just keeping in mind on the service side of things, if you're an installer and you don't do service, think about it. If you had to service this system and you're installing it new, how you might make it a little bit better for the next person down the road.
Well put.
Go ahead.
No, I just said well put on that. Think about the next guy.
Yeah, it's so much of my job is just dealing with the older equipment, and I can always think of a better way, but it's easy. Hindsight's 20/20. Maintenance and just real quick. Obviously, there's higher levels of maintenance for modulating condensing boiler versus a traditional cast iron atmospheric type boiler. Reason being, there's obviously more components involved, safety devices. You've got induced draft versus maybe atmospheric venting. So on your maintenance side of things, annually versus semi-annually, you're going to be inspecting some different components depending on the type of boiler that you're up against. Annual maintenance, heat exchanger cleaning. If it's a atmospheric boiler. Seen a lot of cast iron boilers sitting in the basement next to the litter box. That can cause all kinds of problems, whether or not the thing is full of fur or corrosion because of the litter box or other pets in the home. But one thing I want to talk about quickly is water quality. And one of the biggest things that I see on some of this now aging modulating condensing equipment is related to water quality, and not specifically to any particular brand of boiler, but really all boilers are susceptible to this, whether it's stainless steel, aluminum, cast iron as well. You've got a lot of systems out there being filled with pour water, whether it's total dissolved solids, hardness, whether it's conditioned or not. That's something that if you're not paying attention to is going to keep these systems from lasting as long as they should, probably operating properly. Water quality can attribute to so many different types of failures in the system. Probably some of the slides that we saw here were also related to water quality, like on those air vents. With these fire tube heat exchangers, they're incredibly popular, mostly because they're efficient and easy to install. The manufacturers are moving to those because we've shown as installers or contractors that we prefer them, but they're susceptible to the water quality too. That fire plate up by the burner is where you're going to see systems that have a lot of total dissolved solids, the TDS, or real hard water. That's gonna all that impurities in the water, or the minerals are gonna collect at that up near that fire chamber. I've seen some pretty neat displays of those heat exchangers cut open. I don't have the slides to share. I wish I did. Where they show, the kind of window in the side of that heat exchanger right below that burner plate, and they'll show the water side just filled solid with, whether it's, some type of magnetite or iron or whatever it is, but the solids in the water collect there where it's the hottest point in the system. So knowing that you've got to check your water quality, whether it's service or new install, it's super important. I see water quality issues all the time. And then, of course, on the maintenance side of things, checking the combustion, the venting, gas, condensate lines. I see oddly piped condensate lines all the time, whether or not it's the fittings or the route that they take, but also double trapping or using, believe it or not, copper piping for condensate lines. That's a big no-no, of course, for corrosion. And then checking electrical is something that you're going to see on seasonal maintenance things. It's really going through that checklist, similar to what I had with the venting. You can apply most of that to all of these parts of the install. And what you're trying to do, in my opinion, is eliminate those nuisance callbacks. And then I was asked to talk about basically tools. So must need and must have tools. Listed a couple tools here that I get a lot of feedback from friends in the industry. They ask me, or I ask them. I'm always looking for the next tool that's going to help me on the job. But a good manometer, if you're dealing with gas systems. I don't know that you can install a gas boiler properly without the use of a good manometer, knowing how to use it. Of course, a multimeter, whether it's service or even install, there's always a constant need for the use of a multimeter and knowing how to use it. There's a refractometer that's in the center section there that's going to be used. A very simple one there. I think that's exactly the one that I own. I just found a picture of it online. But you're going to use that to check the inhibitor levels on glycol. We have a lot of glycol systems here in Minnesota. You got to monitor that, in my opinion, annually, but also just to verify that the system has got the right level of the mixture of glycol in it. And then I don't know if you got anything to add to that, Bob.
No, I think that's a good list, and it doesn't take a lot of investment to get that, the right tools to do your job. Probably, especially on high efficiency equipment, you need to be little bit more geared up with your tools and analyzers with the high efficiency stuff than the older gas-fired atmospheric equipment. So that's a perfect list.
Yeah, I guess I didn't mention the combustion analyzer, whether or not you're working on high efficiency or atmospheric equipment. That's a common tool that you obviously need to have and know how to use, and of course they require service. So well thought out tool bag. Really what I mean by that is just look at the tools you use every single day. Those are the ones you obviously need to have in your bag. I could talk all day about tools. It's something I'm passionate about, but you don't need to carry every tool in your truck in your bag, but think about what you need in your bag. Thermostat type screwdrivers, things like that, good wrenches, anything that might be specialized for the equipment you're working on. And then factory training. This was a good question the folks at Caleffi asked me, and I've answered it here as honest as I can. Being busy as a contractor, maybe we've got some folks watching that aren't working out in the field, but maybe on the manufacturing side. This is how I feel about it. I love taking as much training as I possibly can. We're all here doing it on a webinar because it was probably most convenient for us. And the big thing is none of this was a sales pitch, or at least I hope you didn't think it was. That's not what I'm looking for as a contractor. Our time is valuable, and taking time away to either attend training in purpose or in person or attend a webinar online. We could all be out there doing things that are making us money, and hopefully that the training we're attending is going to help us do that, but not so much if it's, turns into a sales pitch. We generally know what the equipment is. We just want to learn more about it, maybe how to service it, how to better install it, maybe how it's going to help us do our jobs a little bit better. And then for us in Minnesota, we've just within the last 5 years added continuing ed requirements for our license renewals. So I'm always looking for training that meets those criteria, because again, I need to get that done. And if I can do it and learn something technical about a new product or something, that'd be great. So, and then my wish list to manufacturers. The list is probably longer than this, but a couple of things that have just been top of mind for me lately are we kind of touched on it a little bit, but boilers that might have optional manifold system for hydraulic separation. I think it would be great as a service contractor if installers were just pulling that boiler out of the box or out of the crate, and that manual or that separator was included with it. Tankless valves for combis, that would be awesome. I mean, I service this equipment and I see so many things that would make my job easier, like a simple set of service valves on a tankless coil or a heat exchanger on a combi that allows me to clean it. I think that there's these manufacturers, it seems to be a race to the bottom price, and it's maybe included in the literature that devices like this should be installed, but you got to purchase it separate, and that's going to weed out a lot of it's going to take a certain percentage of contractors, and they're not going to do that. But if it were just included, we talked about that high point of that on heat exchangers. I feel pretty strongly about that. I think that is an easy way to keep that equipment running at a low cost. And then probably one of the things that I feel really passionate about is just these boiler manufacturers, the equipment manufacturers are offering training. They want, they're marketing their materials to contractors, trying to get them, offering up incentives to have you listed on their website as an installing contractor, things like that. And I just like to see what seems to me to be a kind of a lack of qualification, maybe is how you could put it. But a lot of, it'd be great if there were more of a requirement needed to get your name on that list, whether or not it's attending a certain amount of training or minimum or maximum amount, something like that. So I don't want to rant about that all day long, but I think that there may be some contractors watching today that would agree with me on that. We see a lot of bad installs by contractors that are on those lists, and you wonder how we can better that. I think that more training would be a good start. I think that's it for me, Bob. Let's see where we're going. Yeah, I hope I added some useful information there.
Yeah, I think, I don't know, we kind of ran a little late here, so we'll answer all your questions via email and stuff like that. So we appreciate everybody tuning in today. We had a great audience, by the way, Eric. I don't know if you had a chance to look as we're rolling through here, but thanks everybody for committing, and thanks for your support to Caleffi on everything we do and provide. And I guess with that, unless you've got anything else, Eric, we're going to call this a wrap.
Thank you for the time and opportunity. I appreciate it.
Yeah, thanks everybody, and we'll see you on the next one with Kevin. Bye-bye.